This is the second part of the fourth lesson. Now, always in NetLogo, we have to move to a more abstract, no, before the more abstract level, with the abstract level, we have to remember that the information about NW extension are reported online in the address I shown you in the file of the lesson, and this is the repository where we have all the infos about the NW extension with a short handbook, you see, with all the instructions. We have also locally, but in not so easy to be find the place, in NetLogo docs NW HTML, the same infos. So you can search for them online or locally, but they are not included in the NetLogo handbook. I don't know why, but this is the situation. Here we can discover two very important information. One is about the idea of context, which is a bit limiting the use of networks in NetLogo, a bit limiting, not too much, and one about the confrontation between the agent set as normal or special. A normal, let me introduce immediately that a normal agent set is turtle or a breed. A special agent set is an agent set created while the program is running with turtle with color red. So this is a special agent set, that of the turtle with the color red. Implicitly, this kind of agent set is static, not dynamic. And this is terrible, because in a network, you can imagine to put agent sets, all the agents of a given kind. But while normal agents are automatically adaptive, if you create a new turtle, your agents of the turtles will increase, and the network will be aware that now there is one more turtle. If you create, while the program is running, an agent set of the red turtles, it will not change, because you have to execute again an instruction to change it. It's a pity, but anyway, this is the situation. And I stress that because if you use in a wrong way agent set, maybe your network is not responding to what you are waiting for. Before moving to context, let's have a look to our first NW example. Then we will move to the idea of context. Always the usual problem, also for the code. You see, these are very, very simple examples. In this case, we discover what a context is. We create 3 turtles And as we create them directly, we create also the links with, okay? But we have imported the extension NW. The extensions in NetLogo are used with the name of the extension colon the instruction contained in the extension. In Python, when we import a library with import name, we will use name dot. Here we use name colon. Is a choice. Set context. So create a virtual space where all the elements of the network are contained. Why? Because all the calculation upon the network have to be addressed to the context. As an example, I can create here a context containing only myself and Marco. So when I will do the calculation about our network, only these two agents are considered. Or I can create a context with all the links. It is a limiting situation because if we want to change the space of the network, we have to modify the execution with a new context. I will show you now a few examples. This is very simple. Create, and here we have the reply. The observer has received the message show context. Now I will explain sort and map. And the result is turtle 0, turtle 1, turtle 2, link 0, 1, 0, 2, 1, 2 are the element in the context. So all the calculation will be applied to these elements. The instruction generating the show is a bit complicated. Sort is here to put in order the element of the context, but more and more is here to have the possibility of showing the context, because we have to apply something, a function, to all the elements of the context. And to map a function is a mathematical expression, but also very singular to the English language. In Italian, we do not have it. We have to use applicare una funzione a. To map a function means to apply a function to a sequence of elements. And sort is generating the sequence. NW get context is not a sequence. So sort is simply transforming in a sequence the context. And map is applying the sort to the first, the agent, and to the second part, the links of the context. Anyway, you can memorize map sort and it works. It works, okay? Okay. Map is coming in computers from the old, very old Lisp structure, the first very significant artificial intelligence language in the 50s, so about 70 years ago. Stop. More on extensions, sorry, context. This is only an exercise. I have created it reading the NW explanations online as you have here. larger, 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 stop. Code. Here we have two breeds. The breed of the bankers, and the individual is named banker. The breed of the clients, and the individual is named client. The network rule is that on the left we have the name of the collection, on the right we have the name of the individual. Quite simple. These are names of collections of links. As we have the names for agents via breeds, we have the names of the collection of links via breeds. This is a name. Friendships. And the individual is friendship, the individual link. And these are links constructed in the with way, so undirected, with Pietro and Marco without direction. This is the breed of directed link, so to or from, I don't remember, about account. These are banks, so we have account in bank. We create 3 bankers, 6 clients, we put them around randomly. All the turtles are supposed to create a friendship link with other turtles, so we are all connected with friendship relationships. The clients are supposed to create account to one of the bankers, Friendships links have thickness 0.4 to be visible and are yellow. The accounts have thickness 0.2 and are violet. Yellow and violet. Don't ask me why. Okay? All the turtles have a friendship link. Only a few of them has, each of the client has an account with one banker. Okay? Not so nice plot. Anyway, it is not important. Now I want to make calculations upon this structure. I have to create the context within the structure to apply the calculation to them. And let's look again at the code. To create and show the context, I use an interesting widget. The widget named chooser. Not chooser, sorry. Yes, chooser. The chooser is made in this way. You see? A name that will be addressed within the code. In this case, the names are those displayed here. If I choose turtle links here, if what network equal turtle links is true and the other one are false. So this context will be created and so on. In each case of the create show context button, at the end we show the context and the content of the context. Questions? I repeat, this is only an exercise. I have created a complicated network, and now I want to create a set of context within it. I have pre-declared the context with names. These are names, and I put them in a widget of NetLogo named chooser. The chooser contains a list of possible choices. And then with the if, I activate the context related to a specific name. And finally, always within the block related to this button, I show the name of the context and its content. Okay? Let's verify if it works. I forgot. The show is written in the form output show. In this way, the show is not sent to the last row of the screen, but to the window, output window I have created in the main window, this one. Turtles link, everyone. The name is Turtle Links, and the content is a very long list because it contains all the turtles and all the links for our network. Okay? The wool. Let's choose another case, smaller. Bankers links. The bankers are free. All the agents of our simulation have friendship relationships, but the bankers have also links of friendships with agents which are not bankers. So all the friendship links are shown. Let's see about the accounts. Clients accounts. The clients are Mr. 3, 4, 5, 6, 7, 8, and 9, and 8, sorry. And the accounts are of Mr. 3 with the bank 0, of Mr. 4 with the bank 0. I go at the end of Mr. 8 with the bank 1, and so on. Maybe you are thinking about that this is a very complicated way of working with networks. Sure, it is. But it is a limit of NetLogo. NetLogo is born to move turtles in a space with links, to have interaction, without links, to have actions and interaction. Then they added links. Then they added the first extension network, very, very limited. Then, following the requests, they created another layer, that of the 9W extension. It is complicated, but no other way to have a simple structure running this kind of problems. For just a minute, for following the request, they added also the matrix calculation within NetLogo. Is very, very complicated. But just because they have to add it to another structure. Julia?
There's a way to, in this case, each node has a link with all the others.
Yeah, sure.
But there's a way
only one of the kind of the links that named friendship. Only one.
Sorry?
The other node. Only one kind of links with all the others.
Yeah.
That named friendship.
Yeah, no, of course. But no, my question was, there's a way to, I don't know, a different.
Yeah, here you have the accounts. The accounts are only from client to banks. Anything you want. You can also create one-to-one links, me with you, you with Sandro and no others. All what you are programming. So this is the key. When you create links, you have subjects and destinations. If the subject is a collection all the members of the collection will be linked with the destination. If the subject is a specific title, you will have only this link. Let's have an example. I am here in the interface and I act directly in the command center. Create link, turtle zero, a specific one. Create link. Link is a best name, is a nice name, but it does not work. Create link to which one? Turtle 2. Ah, what my error? Sorry? Exactly. The error you made yesterday.
I learned.
Learning by making errors. It's always a very important way of learning. Ask. Stupid term. Turtle 0. Create. Ask turtle 0. Open square bracket. Open square bracket. Create link to turtle 2. You cannot create. No. You cannot have both breathed and unbreathed links in the same word. I was not aware of that. It is a discovery. As we are using breathed links, we cannot create unbreathed one. Okay, let me simply, I don't want to lose time, let me simply, yeah, but I want to clean, I save this, I create a new space. Okay, and I execute this directly here. Ah, terrible today. Thanks. I act all here. Create. You see that you can write the code in an interactive way. Create turtle 3. Okay. Now the link has been created. If I look here, we have a link from 0 to 2 and the turtle 0, 1, and 2. And in this way, I can create any kind of network in a detailed way as I want. It's only lengthy as well. A very final example about the logo. A general example that is no more in the distribution. It was in old versions of the distribution. I put it here because it is a very rich example. Also with an info sheet with a lot of important information. Okay. This is coming from version 5, I guess, of NetLogo. It's no more distributed. And I have corrected a small error coming from a different distribution, but it works. Here you have the networks Julia was asking for when we started. You have any kind of possible network. But I disagree with this kind of work. As an example, let's create a preferential attachment network and then to modify the layout in any kind and so on. It works perfectly. But what these agents are, we don't know. This is in the majority of the cases, we look at networks where the nodes are unspecified. I am more interested in nodes well specified and then to create between them links. In other terms, I want the network arising from the agents and not superimposed to agents. I will explain that better tomorrow. While I keep alive this sheet, this example, because in the info table you have, we have again to increase the size, you have a very nice memo about all the kind of networks, you see, with links. What is a click? I don't remember, and directly I jump to the voice of Wikipedia. It is very well constructed with all the correct link. So use it as a memo. Okay? Now the more important part. I lost my folder. No, it is here. The more important part. The Python one. In the Git repository of, I forgot, in the Git repository of NetLogo NW, we have also a cheat sheet that for copying at the exam, you know, and it is a nice memo about all the network instructions. You can use also matrices with turtle breeds and so on. Python. In Python, we use the library networkx. You are supposed to install it in the usual way. If you are not Conda users, I am not a Conda user. If you are not Conda user, use PIP program, which is the installer of the libraries. If you use Python 3, use PIP3, install the name of the library, and now it is a work of downloading and installing. NetworkX is a very huge program, library, made by people of Los Alamos Laboratories, and Matteo Marini, that will discuss with you about agent-based simulation after my sequence, I guess in December, if I remember correctly, is a very sophisticated user of NetworkX. As always, let's start with the very first simple example, without agents. Without agents. Is already the max size. I don't know. A first step with NetworkX. I use directly locally idle. I have now installed 371 with small advantages. One is that idle now is working very well. Was not scrolling in the window. Import network X as net, just to have a short name. Import matplotlib pyplot, so the subpart of matplotlib named plotting in Python, pyplot as plt. First step. Now, finally, we have something of very, very well identified. First step, create a graph in the mathematical sense of the term. So, a set of connected elements, a graph. An empty graph. What is creating the graph? The class, pay attention, G, capital letter, is a class. It's not mandatory to use capital letters for classes, but it is a good idea to do that. Graph is a class. So G is an instance of the class graph of network X. Imagine to have an empty something. An empty what? A dictionary. And let me spend 2 words about dictionaries in Python. A equal, open square bracket, 1, 2 is a list or vector. You see? And I can ask what is in A position 0. We were discussing the first day about position 0. We are here in a language using 0 as first element. What in position 0? 1. What in position 1? 2. Sorry. If I ask for position 2, the reply is you are outside the limits, list index out of range. Sure. There is a nice trick in Python that of the negative numbers, -1 means the last element, because if I have 0 and 1, and you imagine to have all the data in a circle, and you go back, you are at the last one. So -1 is 2. If I don't know the length of my list and I don't want to calculate it, simply -1 is the last element. -2 is the previous one, -3 is error because I am outside the scope of the list. Okay? And the dictionary? A dictionary is defined with curly brackets. A equal, open curly brackets, a name, Gabriele, what your weight? How many kilos? How many kilos your weight?
Don't ask me that.
70. Comma. Marco?
No.
And I don't ask.
I can only say that.
100.
There has been a time where I was waking up about 75.
Okay. Let's continue. Pietro?
No, I'm less than that. No, I'm not much less than that.
Ah, Pietro? 82. Okay. Sorry.
When I was a student here.
Oh, what is that? When you were a student here, you were 60 kilos. When I was a student here in this building, I was 65. Invisible. A doctor told me you need to have the same weight. My reply has been, you are crazy. Anyway, this is a special tables with keys. And I can use it jumping to the values by keys. A of Gabriele is 70. The content of a key can be a dictionary. So you can have nested dictionaries, and this is a wonderful structure. Very complicated to be created, but it's not our job. It's the job of Python to create it. And graphs are built upon dictionaries, giving us a lot of power, and you will see immediately.
Well, I'm not 100 kilos.
Do you want to correct? Very simple. No, just to show. If I write, pay attention. Marco equal 10. Now the dictionary has been modified. Okay. We have also functions to manage dictionaries in Python. And the dictionary has a lot of methods. If I a dot and I tab, no, still does not work. It's always not working. It's a pity. Okay, the example. I create 3 edges. Going back to the Julia question, in this case, I start creating the edges. I have 3 elements, A, B, and C. They have names. Names. Julia, Daniel, and Marco. Names. And I tell to the graph, my instance of the graph, to add this edge. Automatically, Network X is also creating the nodes. It is not necessary to pre-specify the nodes. If you want to do that, you can. Then I order to net is my library, to draw the network. But the draw has an effect only in memory. I don't see the result. Why? Because Network X is unrelated with the specific code and application. So it is not aware of the machinery about displaying. And this job is given to matplotlib, and the show is showing the last creation that can find in memory. You see that show has no address, no specifications. It simply keeps what has been just created. Run. An error due to the non-alignment of the last matplotlib version in Network X. We are using a deprecated instruction, but it's not our fault, it's the fault of Network X. They will modify the library. Matplotlib 3 is very, very new. You see the net with the names, they are small, but here you have A, here you have B, and here you have C. You can see them here. Sorry?
Can you explain again what is the fundamental difference between draw and draw network?
Draw is creating the image, the structure of the image in memory, but it has no capability of displaying.
There's no capability of displaying.
And show takes in memory the last created structure and display it. It is a choice of the people of Network X, so they are not concerned with the kind of display are we using. Only in Mac, you can use 3 different ways of displaying things. So imagine what is complicated. Then you have Windows, you have Linux, you have Unix, you have. So They are not doing that. It is not our job. They are managing the network. Okay? Questions? Okay. Simply close this and you have again the control of your job. This is a very simple example. Let's close. Let me open a second one. I won't follow to my list. And agents. Oh, finally, the step I want. I don't want insipid nodes, but I want agents. What a difference. We can also use turtle, but now turtle is not used because you see the class is not importing turtle. The next example is also importing turtle, so we will have two screens, the screen of the turtles and the screen of the network. And then the computer will crash, probably. I have a very simple class, a class only with the method setX, copying locally a value. You already know anything about classes from my lessons. A1 is an example, an instance of A, and we set the internal X value to 10, 2, and we set the internal value to 20, 3 to 30. A symmetric construction. I create the empty graph, and now the edges are between A1, A2, and A1 and A2 are not names, are agents, are addresses of instances of a class. And then the same. Then I have a display just as a memo for me as a teacher to make all the explanation following this simple example. So the next is only a print for me. You will see the result. Let me execute. You can imagine the effect. Not names, addresses of agents. I can superimpose a name. So if I want that the agent A is named Giulia and I want to write there Giulia and then Pietro and then Sandro, I can. But this is a simple example. I can also change the color, change the size. I look to Sandro, put shapes. Again, the shapes of the little boys and the little girls, what I want. So from this very, very plain basis, we can do anything. Imagine the handbook of Network X is a large book. So anything can be done. And Network X is known to be able to run a network of millions of nodes, millions. There is a limit, and there are errors, and Matteo, I am advertising for Matteo, he will pay me, has solved one of the bugs, but the library is so large that it is impossible to eliminate all the bugs. Now I close and I look at the messages. Now, and with that I will conclude my lesson. So let me show you the homework for tomorrow. And the other step will be done tomorrow. The homework for tomorrow is very simple. Following one of the example, try to build a tiny network for your own, and again also in Python the same. So very simple, but you verify if you have understood how to build the network. Now the memo for me. Now interactively, what G nodes are? First of all, what G is an instance of the class graph. Okay, we have created it. Pay attention. The program is no more running, but the memory is always there. It's not been cleaned. So the memory is still alive. Second, G.nodes. The addresses of the three instances that we have created. And what G edges? You can guess. The tuples. A tuple is a structure with two objects. In Italian we have n-nupla. It's the same. A tuple is two. Is an n-nupla of two elements. And the tuples are very quick in execution in Python, but cannot be modified. A vector can be modified, a tuple no. As we have created, you have it. And we have the tuples of all the links with the first and the second subject for each. Okay, this is closing the first tuple. What G node A1? You see the dictionary. Node is the dictionary. G dot node of A1. What a pity. Nothing. Yeah, because we have not assigned to this node some attribute. But we can with this instruction. If this is an element of a dictionary, we can create a new key within it and to add a value for the key. As before, when I modified the weight of Marco from 100 to 10. The dictionary exists. It is empty. Okay, I can add a key. Now, if I ask again gnode A1, it contains size 1. So it is a nested structure. And I can add any detail to my network. It's a complicated structure, sure, but it is very, very powerful. Okay? Sorry? The node exists. The node exists because it has been created when we have created the edges. The nodes are here. These are the nodes. A1 is this one.
Okay, 1 is the first.
Yeah. Now, if I ask gnodes, maybe I can reply in this way. Gnodes data true means show me the nodes and their dictionaries, their data. And you see, the first one has the dictionary within it. Column, dictionary, content. And the content is a dictionary. So I can add any set of keys here. The second one has an empty dictionary, and the third one has an empty dictionary. Sorry, I'm misspelling sometimes the accent of dictionary. Okay? The same about edges. Let's see. This is an edge. And it has, now you know, an empty dictionary. Empty. But I can add a weight. And now, if I repeat the previous question, the reply is the weight. And so on. A wonderful, astonishing, complicated structure. But if you learn to use it, and I will show it tomorrow, you can imagine to have, pay attention, then we will conclude. Last minute of attention. I can have A1 as an agent containing its attribute. A1 as a node in the graph containing other attributes. And I can copy from the attributes in the network modified by other agent to the attribute in the agent, and vice versa. So being able in creating a nice structure of network in Python, we can do anything. And the calculation, what if I want to calculate bitrances about my network? I will ask, please, network X, do that. And network X will do that, because the address is G. No more the trick of the context that we had in NetLogo. No necessity, because we have a mathematical structure here, the graph. And this is why a lot of person is switching to Python, because we have very important element to be used. Okay, with this I conclude my conversation today. See you tomorrow.